So, what we have for you today is a vacuum tube radio from the 60s. We'll be opening this together as we go along, but from the outside it does look pretty good. I would like to start talking about my channel and how it was idling for so long time. But the thing is, if you're like doing something on the internet, you have to do it for yourself, you know? Because like those influencers on Instagram, on all the social media you have, you know, they use things for the others. They start, you know, posing new clothes and makeup and all that sort of stuff. And you know, if you're not doing stuff for yourself, if you're doing stuff just to look good or to impress others, it's gonna suck. This is an old vacuum tube radio from the 60s. The brand is called Silva, as it says here on the right, and there's not much information on the internet, so we'll have to be patient and try to find out for ourselves. On the left here we have the controls. So there's a control for bass, one control for treble, and one control for the volume. Everything is in German, so it's a German built radio. We also have here all the bands with all the programs and all the stations here. And we have down here some buttons. The first one is to turn it on or off. The second one is the phono, which is the one for the phonograph. The third one would be for a cassette player. This is for the long waves, middle waves, short waves, and ultra short waves, which is the FM or equivalent to FM that we have on our radios today. To the right we have this control in which we can change the bands. So this big one changes the long, middle and short waves, and the one behind it, and I'm turning right here, changes the FM or ultra short waves. So this is basically a record changer, and we'll be taking a look at it later after I get the radio stuff all working and all safe for us to try and plug it in. It also has a light here on the top that lights up supposedly when you open the cabinet or not. And yeah, let's go on. It's very important for you to note, electricity can kill you. So it's gonna make you very unhappy if you get a shock. Even a minor shock like 120 or 200 volts AC can kill you. It can make your heart go out of rhythm and it can cause death. So be aware of those kind of things. And messing around with electric components like this one with a power cord that looks like this or has things like this in place is an absolute no-go. So there's no way we'll be plugging this in. It even looks like it got some sort of a very high current going through this connector over here. It's completely destroyed. Let me see if I can destroy it a little bit more. Yep, it just fell apart. So it's even safer like this. But still, do not play around with this. It's dangerous. It can kill you. If you want to do yourself, if you want to repair radios yourself, do at your own risk. And my recommendation is go to electric school before you do some kind of work in electrical equipment. 1 week, 2 weeks of electric school will teach you the necessary things for not to get killed by doing electric repairs. Okay, so be safe. One of the reasons why I got this thing was because of what was inside this envelope. So there's some documentation and some warranty cards. I'll show these things in detail a little bit later, and especially because of this. This is the wiring diagram. So everything that's on this radio and amplifier is going to be here. All the tubes are listed here. So I say tubes. The guys over in the United States, they call them valves. But the Germans, they call it Röhren. And eine Röhre is a kind of a tube or a pipe. So I guess as we're talking about a German product, it would be nicer to call these tubes instead of valves. But, you know, it's the same thing. And then this is going to be like the guidelines for this project. If I didn't have the schematics, I personally myself would be completely lost doing this. So it's a great thing. We have to keep in mind that these electronics, they were built to last. So in the 60s or in the 70s, these things, they were built like for forever. They were nicely built. They were built with hand work. They were built with pride. So there were no spare mades, or there were no cuts made. And all the things that you got, they had this stuff, these wiring diagrams, all the radios and televisions, they had them attached either on the inside of the equipment, on any plate or so, any cover or so, or they had, like this one has, a very nice envelope with everything in it. So, you know, they used to think different than nowadays. Nowadays they make products for you to buy and throw them away and make a whole bunch of garbage. This was a very different era here. It's like back in the day, it was like buying a car today. You would never buy a car that you would not be able to service it or not be able to fix it, that you would have to throw away in a couple of years or so. You would never buy that thing. Like this thing is the same. Back then, if you bought a radio that could not be fixed in case of, or if you made a radio that could not be fixed in case of something went wrong, you wouldn't sell it. You just would not sell the product. And I wish we had the same thinking and the same attitude today with the things we buy and the things we build. Unfortunately, it is not like this. So I will keep this for when we get inside the radio. And then I'll show you the other stuff we have. So we have this control Karte. So it is a card that's for any kind of maintenance that was done to this device. Unfortunately, I don't have any kind of readable date in here. There's something, I have no idea what this is, so I don't know from when this card is. The other one we have here is a warranty card. So this is very interesting. It's a warranty card from Lawrence. And Lawrence was the one that made 1, 2, 3, and 4. 1, 2, 3, 4, 5 tubes for this radio. So this radio has 5 Lawrence tube. And here we have it again, EMVD. It's the same one from this control Karte. So which means that this guy is probably the seller, because yeah, it's supposed to be the seller here. So if we turn this around, it tells me that the warranty is a 6-month period on all of the tubes. And if anything would happen to the tubes, like a mechanical stress, because sometimes people would bang on the radios and stuff like that, and the tubes went bust, the warranty would not cover that. The warranty would not cover overloads. So if anything went wrong with any capacitor, resistor, and the tube got too much current, the warranty would be excluded. So they're basically telling you they would take the tube apart, disassemble it, inspect it, and they will only send the disassembled tube back to you in case the warranty is denied, if you ask for the tube, actually. Otherwise, they will throw the tube away and won't give you another one. If they approve the warranty, they will send you a functioning tube. It doesn't even say new tube, it just says a fully functioning tube, which is pretty fair enough. and they won't give you any money or anything else. So just a tube, and you have to be happy with that. This is also very interesting because it says if sold, it should be filled up by the dealer or the seller, and it's blank. So and this one is also telling that this device hasn't been sold yet, and it's still in the warehouse, and it's also blank. So maybe people wouldn't like to fill papers back in the day, or they just forgot to fill this up, or even maybe, I don't know, this thing was a showroom object. It's also possible. And then on this side, we have on the other side, we have the warranty, as I told you, and the tubes, the specification of the tubes. So we have a ECC 85, ECH 81, EBF 89, EM 84, ECM, I think it's an M 86. And here we would have to, and the maintenance shop would have to put in which tube was changed in case of repair or a warranty or something like that. So, actually, very, very nice documentation we have here. And on top of it all, schematics. I would like to talk a little bit about Lawrence. And Lawrence was a German manufacturer of electronic components. So they were found in 1880, and they remained more or less in business until the end of the 1980s. So 100 years after that. They began doing equipment for telegraphy and for railway signaling. But soon after, they began making televisions and radios. And that's what they were famous at. The founder, Karl Lawrence, was also, this is very interesting, the first person to install a radio antenna in Germany. Until the start of the Second World War, his company was the #1 maker of flight navigation systems, both for airplanes and airports. But as I said, after the World War, they began doing televisions and radios. Well, I think now it's time for me to turn this thing around, get the camera set up, and start taking it apart and see what we have in the back. Just note, I'm not a radio specialist or a radio technician, and I don't have the equipment or the knowledge to set this thing up correctly. So I'll just hope for the best and hope everything works if I fix the components that are, let's say, broken. If you want to see someone that's an artist, a very intelligent person, a very good professional, then visit Mr. Carlson's lab channel. It's gonna be maybe here in the YouTube video or in the video description. I'll put a link to his channel. He's excellent in everything he does. It's a beauty and a joy to watch his videos. You know, just go over there to his channel and check him out. Especially with old vacuum tube equipment, be careful. This stuff is dangerous. They have very high voltage inside of them when they're plugged in. So this is it without the back, and just note the detail. How nicely made, how nicely built and everything was back in the day. This went out up here and here, everything nicely built. Not the safest, because I suppose there is 220 volts inside this line, so it's not the safest, but very nice, very built, very nicely built. And back here, I took the screws off. This is actually how it looks like. So this is all the dust and everything. We can see the dust hanging off. This This is how the radio looks like on the inside. I already got the radio out of the case. Well, there were only 4 screws in the bottom, so I loosened the screws, removed the screws, and I got this radio halfway out, taking care not to bang anything or destroy anything, and it's actually very easy. I don't have to remove anything at the front. Importantly, when you're doing repairs like this, mark the stuff you're about to take off. There's actually another cable back there, that's the speaker wire. I'll have to take a look at that. So I ended up opening this back plate here, which I thought was the easiest option. And then in here, these 2 cables were soldered down to that plate. So I desoldered them. And inside we have 2 speakers. I don't know if these are the original speakers or if they got replaced someday. And then up on top of the speakers we have the antenna that just goes around inside the chassis. Goes around to both sides. Very neatly packed inside the chassis so no one can see the antenna from the outside. And here we have the radio. The next step for me right now is going to be cleaning everything. So I'm going to clean all the radio components, maybe with a soft brush and a little bit of a vacuum cleaner, just on the lowest setting. Going to clean this thing up. Going to sit down, take a look at it, and go step by step. Before you plug this radio in, please replace the capacitors and check all the resistors and all the components to see if the values have not drifted away. By doing so, you will ensure that your vacuum tubes won't get over current or over voltage when you plug the radio on, and ensuring that nothing is gonna burn. Actually, these vacuum tubes, if they were kept quite nicely and stored, and no one done any kind of atrocities to it, like connecting this radio and trying to power it up right away, they might as well be all okay. Welcome back. Now we have the radio cleaned, everything vacuumed and brushed off, all the dust and everything. And I saw one little problem at the bottom. There was one inductor that was broken off, but no big deal. I got that fixed pretty quickly. I did some checks. I already checked the fuse. The fuse is actually good, but the terminals that hold the fuse back here are completely oxidated, so there's no way this fuse is going to make any contact with those terminals. I'm going to use the Dremel a little bit later on to try and clean here those contact pads. And after that, I'm going to start doing some testing on this radio. So I have the schematics here. As I said, I'm no radio technician or radio expert, so I was trying to figure out how everything works. One of the things that I saw and I would like to test is this part here with the filaments to see if they glow. So the idea is I'll disconnect this part of the diode here, just desolder it, and then I will plug this transformer to the mains, not to mains, but to my insulation transformer that's now set to 24 volts, so 10% of the voltage, and then I'll do some measurements, see if this rating here is correct. I'm expecting it to be a 6.3 volt because all the tubes are 6.3 volt tubes, so running at 10%, 6.3 volts is an easy math to do. I'll expect this to be here present. Of course, before I plug it in, I'll do some measurements, see if anything's shorted out or so. And then I hope to see if there's current, and then maybe the lamps will come off very, very faintly. Maybe the tubes will start to glow. I'll see that. I'll also check this switch here, the main switch, to see if it's also working. And then after that, I'll do I'm gonna go check this diodes here. These two leads over here that go inside this tube that we can see down here, just barely see, they go to my on-off switch. So mains come in here, go down to the switch, and comes back inside the transformer. What I'll do, I'll just do a quick measurement here to see if the switch is working. So I have the leads now connected to the switch, to the terminals. I have my multimeter here set up. I'll just press the button and see if the needle moves. So it went down all the way almost to 0, which is pretty much okay. Let me press it again. Needle goes back. Once more. So there seems to be something going on with the switch, because if I press it many times, it goes off. Here shows me a high resistance, so this is no good. See? So the first diagnostics were already done. The switch might be oxidized, so we have to take a look at that. Now, in order to get to the switch that's underneath here, I will have to remove this little board here. So I have to bend these 3 tabs here back and try to remove this board. There's some desoldering that has to be done underneath. I'll desolder everything, put this board back here, and then I'll be able to clean the switch real good. There's also some other work that has to be done here, like changing this cap, this electrolytic, and it would be impossible to change this cap without removing this plate from here. So might as well do it now. I've already straightened the tabs so that I can feel some movement. I have the radio in a upside down position right now. So what I have to desolder are these connections here. There's one connection right here. There's another connection right here. Maybe these 2 wires that go to the tone potentiometer. And then there's another connection down here that I'll have to desolder. And if I go further down, let's see, there is another one back here. And another 2 connections. This is the state of the switch, of the power switch. So I just took it apart to see how it looks like, and this is it. So now I'm gonna basically do everything I need to clean that power switch, because it's the first problem I got. I'm gonna do step by step, and I'm gonna do everything to clean that thing up real nice. So I used a little bit of isopropanol on the surface of the contact, and most of the grit, or most of the dirt or the burned stuff just came out right away. And there's still a little bit. I think it will be okay, but I'm gonna use a soft wire brush and the Dremel and see if I can get that little thing that's stuck inside of there out. As for the contacts on the radio itself, they're underneath here. So I'm not going to be able to show this on camera. I think we can see a little bit of the contacts here. Yep, I'm touching them with the cotton swab. So I'm going to do the same tactic with the cotton swab, a little bit of iso alcohol, and try to clean those off. I ended up having to desolder a lot more than I was expecting to. So I am a little bit out of my comfort zone right here. I hope everything is gonna be okay. So let me do this here quick. Let Let me see if I can show you how the switch mechanism works. I got everything back together. I got everything oiled and cleaned and everything. So this is how it works. You press once. I'm just gonna press the switch with my finger like once. This thing moves the switch to one side. When I release it, this little spring here pulls the arm back. I hope you can see it. And then the arms back here moves to the other side. So when I press the switch again, it then detaches to the other side. As you can see, it moves from side to side. Underneath, it's pulling one of these bars that looks like this one, the one that I had before. That's switch bar, back and forth, switching between the two contacts. One of the contacts is a blank contact, and it's used for the off position, and the other one is a on contact that's used for engaging the power. And here you have the switch contact, and this part here locks the mechanism in place. So I'm now pressing the phono button, so if I press it down, it's gonna move from here to here, and it's gonna stay in position until I touch one of the other buttons. If I touch one of the other buttons, it goes back. So this is basically how these switches here work. To be honest, they all look pretty clean, the other switches, and I guess it's mainly because they don't have current or a lot of current going through them as the main switch has. So I'll clean them up just with a little bit of alcohol. I'm not going to take them apart. I'm just going to come in here with something like a cotton swab and just try, a little bit on both sides. See if I get them clean, and then I'm going to move on. About the fuse, like here, I got it in on the top so that it works, but then again I'll have to remove these two rivets here down the bottom and clean the pads with a metal brush, or maybe even do something here up front with a different fuse holder or something like that. So I'll still think about what I'm gonna do. Maybe I'll just do the easy way, quick soldering something here up front, or maybe I'll do the whole job. I ended up doing a lot of desoldering of components in the meantime. This is the Diode Rectifier. I used my multimeter to test it, and it's just completely infinite resistance, so it's not letting anything through. So I'm gonna desolder it, I'm gonna test it again and see maybe I tested something wrong or something like that. And here I have some capacitors that I removed. This one on the left, here you can see it better. I'm pretty sure it is an electrolytic capacitor, so this is gonna get replaced. This one, I'm not sure. I have no idea what kind of capacitor this is. I actually don't know. It seems to me that it has a polarity, so it could be an electrolytic. I'll have to Google on this one. Here's another one of those electrolytics, and there's a big capacitor on the board down here someplace that I'm also going to replace. It's actually a big capacitor with 3 capacitors inside. So I'll have to order 3 capacitors, or maybe a similar replacement one. But yeah, these little ones, no idea what they are. These capacitors here, I also have no idea what they are. I read something about Styroflex capacitors, but this thing here really has a hole in the middle, so it's very interesting to know what kind of capacitors these are, because there's a lot of these capacitors on the board or similar ones, and I don't know if I have to replace them or not. For the first part, I'm gonna replace these and then see where it goes. Welcome to another day. There is a guy on YouTube, his name is AVE. He says, you gotta piss with the cock you got. So this is actually the cock I got, so yeah. I have this little setup here to test that diode rectifier over there. So I have it connected to a transformer. This transformer here is set up to output 115 volts. And I did a little bit of math. So I attached a 42 watt lamp to achieve what I think is the maximum power output of this piece, which is 0.1 amps. So if I turn the power on, you guys can see that the diode is working. It is rectifying the AC and giving it to the lamps. And it's showing me the rectified AC, which is now has turned to like pulsating DC with a frequency of 99.4 Hertz and a peak to peak of 122 volts. So everything is working nicely. And as I said, I'm actually learning as I go because I'm no radio technician, but those diodes cannot be tested with a multimeter. So the test that I did yesterday with the multimeter, that was just basically nothing. I would have thrown this piece away if it wasn't for me looking in the internet and finding information in a forum how to test these guys. So I got the radio working. It was a matter actually of replacing all the electrolytics. I replaced some capacitors that I thought were like paper capacitors. And then after doing a little measurement on this tube, I decided to replace this grid coupling capacitor here, because I found out that the voltage on this pin 8 of this audio stage amplifying tube was at around 16 volts plus. And I said, well, looks to me to be a bit high. And this is already a tube that runs hot, so I don't want this tube to be amplifying more than it needs to. So it has now a new capacitor. And I added this resistor here. It was on the diagram, but it was not installed in the circuit. So I ended up adding this resistor so that I go back to the original design of this radio. I got the radio now hooked up to line voltage, so 220 volts, which is it's more about 237, 240 volts, what we have nowadays. Yeah, remember this radio was made to be powered up with 220. I will go back to that point later. And here I installed, at this transformer line here, I installed a fuse. At this transformer line here, I also installed a fuse, so both outputs of my transformer are fused, and the input was already fused and is still fused. Let me show you this in a moment. The one down below is the fuse for the heating circuit. The one on top, there should be a fuse in here. I'm just measuring the current. I will be measuring the current with you guys. It's the fuse for all the electronic circuit, the amplifying circuit and the radio circuit whatsoever. And back here I have another fuse, which is the fuse then for the whole transformer and the whole radio and the switch. And to this circuit I also added this relay. I think it's a little bit overkill, but hey, ain't no kill like overkill. So I got this guy added up here. How this basically works is when you press this on or off switch here, this is ein is on, aus is off. When you press this, it used to be, remember, it was completely blacked out and it was not working, and I had to do cleaning of that switch. So to avoid that, this switch is now just powering the coil of this relay. And when the relay gets energized, the relay closes the contact and gives then power to the whole rest of the circuit. I mean, to the transformer and to whatever I might hook up to this output of the relay. So this is basically what's working. On the top here of the radio, we can see some new components. There's a new resistor. This resistor was completely off. So what I basically did, I went on the wiring diagram and I was checking point to point, measuring resistance. Some places you have to remove the component to measure the resistance because there's something else in the circuit that gives you a false reading. So this one was completely off, so I had to replace it. The other ones are good. All these, this capacitor is also good. Well, I think it's good. This electrolytic, I don't even test old electrolytics. If they are 10 years or 15 years old, I just throw them away. Here there was a 2 ohm resistor. I could not find a 2 ohm resistor in my box of resistors, so I took 2 times 1 ohm. It's basically the same. It's just 2 resistors doing the function of 1. Here's another one that I had to replace that was completely off. And this capacitor here, let's see if you can see a new capacitor back in here. My finger's pointing. That's the one that I showed you here on the diagram that was leaking this capacitor here. It's strange, it was a ceramic capacitor, a Wika capacitor, but yeah, I guess not all of them are good. So that was another replacement here, a new resistor, and this capacitor here also got a new one in place. I think that was an electrolytic that used to be here, but anyway, we have a new capacitor. This capacitor here, of course, electrolytic, new. Yeah, it's basically what I've done on top here. Of course, probably you noticed it. This is the new power cord. It's a little bit special here. It's nothing unsafe. It's just that this insulation stuff here. It's kind of like a rag, a wrapped up rag. Doesn't, keeps hanging off in the breeze and touches maybe a hot transformer or something like that. So I just glued it in place. It's good enough for the girls I go out with. Anyways, here you have the grounding point that I made here with a lot of power. Let's see if we can, oh my god, yep. And I added a ground to the radio, so the chassis is now grounded. Remember, depending on the radio you have, you don't have an input transformer. So those All-American 5 radios, they're gonna have live voltage or ground, depending how you plug the plug, on the chassis. So if you were supposed to ground the radio like that, you would just create a dead short, depending the way the plug is in. So yeah, I don't know, be careful what you're doing. Know your radio before you do stuff. Just remembering, if you guys want to go in detail how to fix up these radios and how to do the plate measurements and stuff like that, you can see this is the audio output stage. It got hot once and it still gets hot. This is a tube that runs pretty hot, but I think it's running at a normal temperature. I have to go and look into it, but it's so hot that you cannot touch it. So that's how hot it is. And basically what you do is you want to have this lead, when you got the radio turned on, you want to have this lead attached to ground at all times. So you're only using one hand, not to electrify yourself when you touch 2 things, because the chassis could be referenced to ground. And in most of the cases, the chassis is referenced to ground. It's not referenced to the same ground. I'm not talking about the same ground that you... Let me show this on the diagram. So, the chassis, as you can see, is referenced to ground. Or maybe you cannot. Now, the chassis, as you can see, is referenced to ground, or the negative, B minus. So the chassis is B minus. If you touch your B minus, and you touch this one here, which is basically the same wire that goes to the plate of the tube, or to the plate of the tubes, with 275 volts 270 volts with the phonograph, for you to be very lucky, it's gonna give you a very bad time. You know, it's gonna hurt. So you don't want to be touching the chassis and probing stuff around here and putting your finger into stuff, you know, fingering here and stuff like that, because this is no transistor fanboy electronics that runs on 5 volts and you can lick on it and nothing's gonna happen. This has power on it. This is vacuum tubing stuff. This is a lot of voltage going around here. This is, yeah, it's not fun. What? It is fun. It's not fun if you touch it. I guess you know what I mean. You have basically this lead attached to. You can do it way. You can do like this. Here, and then you attach this to a known good ground. Be like this guy here. This is a known good ground. All right, you ground on one side, and then what you basically do is you put your guy on volts DC, depending on what you measure. If you want to measure the output of the transformer, you go to the volts AC and you measure how much the transformer is giving out to you. Then you go to volts DC and you start probing around. You know, you look on the schematics how much the voltage should be, stuff like that, and start probing, and you see where the voltage is and where the voltage is not, and you try to fix the problems. If you're really getting serious about this, you should. You can also probe this with an oscilloscope. Just make sure your oscilloscope can handle the voltage that you're going to be putting in, because some oscilloscopes, they don't like the 300 or 400 volts that some of these radios might have. So just watch out for it not to destroy your equipment. But a multimeter, a good multimeter like this Fluke one, this one can also do the job. The problem is it cannot measure capacitance, which is something you might or might not need. And it can only measure amps DC, as you can see here. So it's a cheap one. It might cost you $5. It can also do the job. The other thing that I do, I usually mark the components. You see this one has a 2 dot. And if I go to my wiring diagram, I see 2 dot. Oh, this is this guy here. So I know which component was where. So this one is got replaced. This is a very bad capacitor. It's a WEMA Duralit. So I read it on a forum that these really go bad, and I don't want to risk it. We can actually test this one, see how much it's. I'll put it aside. This is another electrolytic capacitor. You see, it's the 3 dot. So if I go to the wiring diagram, it's this here, 100 microfarad, 15 volts. Yep. Then this one also got replaced. Then these were the 4.7 that are attached from here to ground, which are now replaced by these two here. So I don't know if this one was bad or not, but I replaced them anyways. This is the one that was leaking to the grid. So I ended up replacing this guy. Another one that was in this circuit, I think it was here or here. Yeah, this part of the circuit. I don't know what type of capacitor this is, but these green ones, they could be paper capacitor, like paper foil, and I don't want to risk it, because the paper capacitors, in resin, they really go bad after time. So yeah, I just saw them and I thought to myself, yeah, I'll order new ones. There's another one. That's the only two that I could find that are green like this. So yeah, it went to the bucket. These are the resistors that are completely off. This is a resistor that's off. And there's the other one. Another one that's off. And this one, you can even take it apart. So this resistor, yeah, clearly not the best anymore. And another one of those foil capacitors. So I'll put the fluke to work and let's try to measure these capacitors to see if we can. Got the fluke ready to go here. Let's try to measure the capacitance. This should be a 22 nanofarad capacitor, so let's try and see how much this is gonna be. Yep, it's a 23, so that's pretty much okay. For the meter, remember, it only measures capacitance. It does not measure if this capacitor is leaking. For that you need a leakage tester, or you can do one yourself. You can go online and see the schematics. Remember, this one is supposed to hold up to 250 volts. Now we have this guy here. It's 22 nanofarad also. So let's have a look at this one to see if it shows anything. 22 nanofarad, spot on. This is a 4.7 nanofarad. Let me see how much it shows. Oh, it showed an 8 here. 5, 6, 5. 5 or 6, yeah, it's a little bit off, but not dramatic. 5, 6, yeah, same thing. Now this one should be a 5. So it's a 7 microfarad. Oh, a little bit more capacitance than what it should have. This guy here should be 100. It's a 125. So yeah, we can see that the capacitance on these guys, they really drift away. So yeah, it's good to have them replaced. 11? Oh, how much is this supposed to be? This is supposed to be 22, 2,200 picofarad. So it's I think it's a 22 nanofarad, and it's measuring at 12, 13, 12. So this is clearly way off. These are really the bad ones. This Wima, Duro, Lut. They are really bad ones. Let's have a look at this guy here. This is supposed to be I think it's a paper capacitor. 2 nanofarad. Is this right? 2,200 picofarad. I think it's a 2.2 nanofarad. I think it's right. And this one, I just cut the leads completely off. Let's ignore this one. Okay. Just added it in just to keep the project as original as possible. So there's basically nothing else that was done in the radio. Inside here you have the FM tuning circuit. There was basically also nothing done to it besides testing, probing the resistance probing and probing all the voltages. So basically when you turn a radio like this on for the first time, maybe you can do it on 110 volts and you start measuring all the 110, I mean half of the voltage, and then you start measuring all the plate voltages. Yeah, because you see I even have the values here. So you start measuring the plate voltages and then you start measuring the grid voltages to see if anything is completely out of the normal. Like in my case, this one was completely high. So if you see something that's not normal, you just try and look for where it's coming from. So maybe let's say this guy here is shorted to ground. Let's say there's no plate voltage in this tube. So you might look for anything that could short this circuit to ground, and then you see maybe this capacitor here could be shorted and will be creating, after this 2.2K resistor, which actually measures 2.2K resistor, a short to ground. So you have to just start figuring stuff out and see where the problem might be. And what I also did, I wrote all the resistance values here. I still have to do the final diagram for this radio, and yeah. And you see, like maybe like this resistor should be at 300K. It's 261K, at least what I measured was 261K. You know, these are old resistors. I don't really bother that much. You know, if it's a little bit off, I would say plus minus 10%, and you know, you give it a little bit more, and it's gonna be just fine. Like this is supposed to be a 1.6 ohm, is a 1.6 mega, it's a 1.7 mega, so you know, just I don't sweat because of stuff like this. After this, powering everything up and measuring all the plate voltages, also this tube EM84 here, the grid voltages. Remember, grid voltages are usually not high, unless this grid here, this is kind of like a 70 volt grid. Yeah, I don't know why, but it's pretty much high, but it's spot on with the voltage. And so if you see like grid, like this grid here being timed with 15 or 20 volts, then you might ask yourself if there's a problem. Now, welcome to the underside of the radio. As we can see here, these two capacitors were added in just for filtering. So this is the input of the diode rectifier. This radio has no tube rectifier, it's a diode full bridge rectifier, selenium diode. If it works or not, I don't know. I just know one thing, it was added there before. There were some other type of capacitors. There was those polyester type of capacitors were there. I just replaced them for film capacitors, just you know, to keep it the way it was. It is supposed, on the diagram, supposed to have a capacitor between line, ground, line, and ground. But what happens is, and I think this is the reason why these capacitors got moved over to here, the problem is if you have the capacitors here, and the radio is plugged in, and it happens that you got ground, your live wire here, it's gonna go through your capacitor to ground. So you're always gonna have some little bit, maybe a filtering or a current flow through this path. If this capacitor goes bad and it shorts out, all the hell is gonna break loose because you're gonna have a short here in the circuit. So I'm not the kind of guy that's gonna be unplugging the radio all the time and everything. So I thought maybe I'll just stick to what the guy before me had done and see if the radio creates a lot of hum, a lot of noise. Then I might have to add some filtering here, but then I would have to buy those Y or X capacitors. I would have to look into it. But so those Y capacitors are special capacitors. They're designed for not to fail shorted. So it goes up to the 50 volts pretty quickly. And now we can try and zoom in to see if there's any kind of noise. As we can see, I'm pretty much happy with the way this DC voltage is coming out of it. It shows me 600, 800 millivolts peak to peak. And yeah, the frequency just keeps jumping around, so I'm happy with it. So also very important to note, when you power these things off, I power it off right now, you see that the voltage remains more or less the same. That's because the capacitors that we installed, the new ones that I installed, they hold the charge. So what I have here, I have a very high resistance resistor. It's a 60K, I think. And I'm just gonna short the capacitor with this resistor so that the voltage can slowly drop to a reasonable value. I got the radio plugged in to mains, so we have mains here, input of the transformer. And I have the fluke attached where I put the fuse in here, in place of the fuse. So I'm just measuring the current that is going out of the transformer inside of the diodes through the fluke. So I'm basically measuring the whole current, like the current the diodes are using, the current the plate, the tubes are using, just to make sure that everything is fine. And as you can see, I already did this. I already did the measurement of current here. This is not as exciting, you're just measuring the heating current. But here we can take a look at some different settings in the radio, what happens. So now I got the fluke on. I'll turn the radio on and you guys will notice that the lights will come on here on top, these two, and the plates will start to glow and the current will slowly rise, which will indicate a very, very slowly electron flow inside of the tubes. The hotter the tubes get, the more electrons flow into it. Just another thing, before you turn a radio like this on, you gotta make sure you have a speaker attached to this transformer. If you don't, the electromagnetic, the inductance inside this transformer will kind of backfeed to this plate and will kind of raise the plate voltage, and it could damage your tube if you do it for too long or if you even do it. So it's a good practice. Hook a speaker up every time you turn a radio on. This radio can not be turned on without a speaker, because if it's inside the cabinet, the speaker cables are soldered to the output of the transformer. So yeah, it's kind of like a safe thing. It's not like the new amplifiers that you can unplug the speakers and stuff. This is soldered. So I got a speaker hooked up. It's not a 5 ohm, it's a 6 ohm, but it's a 5-ish. 5 and 1, it's almost a 5. So let's turn the radio on, let's have a peek. Radio is on, you can see the filaments. And I put it on FM. So we can see the current starting to rise. With about 100 milliamps, we might start hearing something. If it's tuned to a station. I don't know if it's tuned to a station. Does it look to be? Here. I forgot to plug in an antenna. So got the antenna plugged in, and here we have the current. So this radio is drawing 140 milliamps. That's exactly what I have on the plan, which means everything is fine since yesterday. Nothing has changed. This here is very nice. Let me try to zoom in, show this to you. This here, now you guys can look this tube up on the internet, is the EM84. The one here up front, EM84. And it has this fluorescence on the front. Basically, how I understand is signal comes in here, already demodulated, everything done, so just audio signal coming into this tube. And this tube has the function to re-amplify the signal if it's too weak, or to let the signal pass through. So the more it amplifies, the more negative this control grid here on top is gonna get. So my understanding is the less electrons are gonna flow through this tube. So if the signal is weak, the audio signal is still weak, it's gonna amplify a little bit, and if it's strong, it's gonna pass it through. So this is what it's showing me here. So if the signal gets weaker, this tube is now amplifying, trying to compensate it, and showing me the signal is weak. And if it gets stronger, these two come and get together. If I find a very strong radio signal, let me try to find one that's pretty strong. I think it was in here. So here's a very, very strong radio signal. You can see when I tune into it, they both close on top of each other. So it's a very beautiful indicator of how strong the radio signal is, or how good tuned in it is. So basically, now I have the AM band, the long wave. The problem is the long wave doesn't work anymore, so the problem is it doesn't work. We don't have any stations anymore in Europe to tune into. So the only thing I can tune is sporadically some noise, which I think is a shame. But anyways, if I go to the phono setting, we can see this current for the electronic circuit is dropping to 108 milliamps. And this is basically just being drawn from that one tube, from that audio output tube. So I really don't know if it's normal for that tube to be drawing so much current. But I did what I can do. I measured all the voltages, and all the voltages that are listed here in this diagram are correct. They are spot on. Maybe just 10% higher, maybe 10% higher or lower, depending on which side. So I don't think I have any problems with the circuitry. The thing I believe it might be drawing so much current because the voltage, the input voltage is a little bit higher, is at 20 volts higher than it's supposed to be. Or because of a phenomenon called gassing, which causes the tube to conduct inside of itself. So I read this in one of the forums. I don't know if it applied to my tube. But on the other hand, this ECL 86 is a very strong tube. It's a tube that can amplify phono by itself. So, yep, it's a pretty strong tube, and I think a tube strong as that one will have to get hot sometime. Okay, this is basically it. I'm done with the radio stuff. I'm just gonna add this resistor here, try to bring this voltage down and do some more measurements. And then it's gonna be time to put the radio back into the case. The radio is now back into its case. So, as I mentioned, this resistor here is new. This resistor is in series with the transformer, so it's lowering the input voltage to 220 volts. And here we have everything back in place. No. This is the front of the radio. So here we have the scale. This is everything is just AM. And down here we have our FM scale, which is selected now. Here, if you notice, if I change the station just a little bit, you see this tube on the left, the EM84, indicating how strong my signal is. So the last this tube has to amplify, the further those two come together. And down here, of course, our PE66. I have it on this kind of improvised stands. I still have to test this to see if this is better, or if it is better that it sits directly on the wood. But I guess it has these springs here for something. I still have to test this guy. And what I still have to do, I still have to change the needle, because the needle that was here was totally destroyed. Of course, that's to expect. So I ordered a new needle. It's coming maybe next week. So next week I'll be able to test this completely. And the most important thing, when you do these kind of repairs, always think about the next guy. And the next guy is always, not always, but most of the times is you. So it's important that you have the schematics that you worked on, even if it's in a bad shape, the way it is right here, like completely destroyed and everything. But if someone sees this, like if it was me, if I saw this, I would say someone dedicated time and worked on this radio. So it's a good sign. I would say it's a good sign. So I have the schematics with all the measurements, the voltage measurements that I did and all the changes that I did, and some more voltage measurements that I did here. Because of course the fuses that I put on the output of transformers, like the fuse 2 and fuse 3, which are fuse 2 is 250 milliamps, fuse 3 is 3 amps 15. If anything happens, if the fuses blow, two things. The fuses are, let me show you. The fuses are behind the transformer, so they are back in there. So if anything happens, if those fuses blow, I would have to remove the chassis, at least take it out. And doing so, I'll be inclined to measure current again and see if there's something short, if there's something wrong going on with the radio. Because just replacing the fuses, it's not a solution, it's just a remedy for something else that is going on with the radio. So if one of those fuses ever blows, the chassis is coming off and I'm going to take a look at it. Another thing that I've done was on the output here, there are two speakers attached, and one of the speakers has a low pass filter capacitor, which was an electrolytic, one of those duolite DIMA, and of course it was off. It was supposed to be 4.7 micro farad, and it was 7 point something, so it was totally off. So I replaced that one, and after looking at this and seeing that it is grounded, like one side of it is grounded, I chased the wire, this wire here, the ground wire, and I attached this ground wire to the negative side of the capacitor. So I know it's not ideal to have an electrolytic capacitor over there, but I mean, it was an electrolytic before, it didn't blow up, so I put a new electrolytic there. See what happens. So welcome to yet another part of this very, very extensive video. This is taking way longer than I could ever expect, ever imagine. And the reason being is once I had to travel in between for 3 weeks, and then I had to order some parts on the internet, and then this is very interesting. I ordered some new needles for this PE66, and what I got were some needles for a Siemens or a Philips record player. So I thought I could do a little bit of a fabric hobble and try to adapt this needle into this PE188 kind of needle holder, but that just went terribly wrong, and I managed to destroy one of these needles. And then I talked to the seller. He said, listen, it's my mistake, I'm gonna send you 3 of the ones that you order, and please send yours back as soon as you got this nice envelope here. So I'll be opening this envelope up. I already destroyed it because I removed the address and such. So let me open this up and then see what we got. I have the radio turned on because I attached this after the relay, so this lamp is now fused and it's after the relay, so if I turn the radio off, the light also goes off. It wasn't like this before. It was supposed to be connecting to the line at all times, so when you open the door this would always have light so you could do your record stuff, but I just don't like letting stuff connected to the line at all times, so I changed or modified it. I think it's a little better to see now. You just put the needle in like so up until the back there, and then you slide this clip here over the needle, and there you have it. I already have the new needle installed. This is just an arm lock here. This is a fully automatic turntable, So if I put this on, let's say, just to make it a little faster, 78, and I can put the radio on the phono position. I don't have to, but this way we can hear something out of the speakers, or out of the speakers, yes, that's correct. Then if I push this lever, you see the turntable starting to turn. It's gonna try to drop the record. Since there's no record being dropped, it stops all the action automatically. So if I were to put some records in here, let's say I can put some 45 single, let's put this Pet Shop Boys record here. You can stack a bunch of records. Let's do that. Let's stack some records here on top of it. Let's put this Let's Dance from David Bowie. And You Can't Always Get What You Want from the Rolling Stones. And then let's put the Don't Worry, Be Happy. Okay, we have now 4 records. So anyways, when you got this, just set the speed. So this is 45. And you put the needle in the right place. This is the wrong one, 78. Now it's 45. And you just push that switch one time. It drops the record. The arm goes to the record and sees the diameter, so measures the diameter, drops the record down, goes to the start of the record and starts playing it. I will have to edit this out because of copyright. Let's have a look at the record change in action. Just a beautiful mechanism. And remember, there's only 2 electric things in this whole device. You have an electric motor and you have that switch which kills everything. So if I press that switch, if the arm rests on that switch back there, everything stops, everything's dead. This here is mechanical. Everything that you see here, the record change, action, everything's mechanical. Even the speed selector is just a wheel, a rubber wheel that changes the transmission between the motor and the plate. So everything's mechanical. It's just amazing. For me, it's more complicated than the modern electronic, fully automated. I got this little setup here because I was curious to see how many grams of tracking force this arm is actually putting on the record. So 8.16 grams.